Next question is: a DevOps engineer is working with an application deployed to 12 Amazon EC2 instances across 3 availability zones. New instances can be started from an AMI image. On a typical day, each EC2 instance has 30% utilization during business hours and 10% utilization after business hours. The CPU utilization has an immediate spike in the first few minutes of business hours. Other increases in CPU utilization rise gradually. The engineer has been asked to reduce costs while retaining the same or higher reliability. Which solution meets these requirements? A. Create 2 Amazon CloudWatch events rules with schedules before and after business hours begin and end. Create 2 AWS Lambda functions, one invoked by each rule. The first function should stop 9 instances after business hours end. The second function should restart the 9 instances before the business day begins. B. Create an Amazon EC2 auto-scaling group using the AMI image, with the scaling action based on the auto-scaling group's CPU utilization average with a target of 75%. Create a scheduled action for the group to adjust the minimum number of instances to 3 after business hours end and reset to 6 before business hours begin. C. Create 2 Amazon CloudWatch events rules with schedules before and after business hours begin and end. Create an AWS CloudFormation stack, which creates an EC2 auto-scaling group, with the parameter for the number of instances. Invoke the stack from each rule, passing a parameter value of 3 in the morning, and 6 in the evening. D. Create an EC2 auto-scaling group using the AMI image, with the scaling action based on the auto-scaling group's CPU utilization average with a target of 75%. Create a scheduled action to terminate 9 instances each evening after the close of business. Correct answer is B. Next question is: a DevOps engineer must improve the monitoring of a finance team payments microservice that handles transactions for an e-commerce platform. The microservice runs on multiple Amazon EC2 instances. The finance team would like to know the number of payments per minute, and the team would like to be notified when this metric falls below a specified threshold. How can this be cost-effectively automated? A. Have the development team log successful transactions to an application log. Set up logs tash on each instance, which sends logs to an Amazon ES cluster. Create a Kibana dashboard for the finance team that graphs the metric. B. Have the development team post the number of successful transactions to Amazon CloudWatch as a custom metric. Create a CloudWatch alarm when the threshold is breached, and use Amazon SNS to notify the finance team. C. Have the development team log successful transactions to an application log. On each instance, set up the Amazon CloudWatch Logs agent to send application logs to CloudWatch Logs. Use an EC2 instance to monitor a metric filter, and send notifications to the finance team. D. Have the development team log successful transactions to an application log. Set up the Amazon CloudWatch agent on each instance. Create a CloudWatch alarm when the threshold is breached, and use Amazon SNS to notify the finance team. Correct answer is D. Next question is: a company is migrating an application to AWS that runs on a single Amazon EC2 instance. Because of licensing limitations, the application does not support horizontal scaling. The application will be using Amazon Aurora for its database. How can the DevOps engineer architect automated healing to automatically recover from EC2 and Aurora failures, in addition to recovering across availability zones, AZs, in the most cost-effective manner? A. Create an EC2 auto-scaling group with a minimum and maximum instance count of 1, and have it span across AZs. Use a single-node Aurora instance. B. Create an EC2 instance and enable instance recovery. Create an Aurora database with a read replica in a second AZ, and promote it to a primary database instance if the primary database instance fails. C. Create an Amazon CloudWatch events rule to trigger an AWS Lambda function to start a new EC2 instance in an available AZ when the instance status reaches a failure state. Create an Aurora database with a read replica in a second AZ, and promote it to a primary database instance when the primary database instance fails. D. Assign an elastic IP address on the instance. Create a second EC2 instance in a second AZ. Create an Amazon CloudWatch events rule to trigger an AWS Lambda function to move the elastic IP address to the second instance when the first instance fails. Use a single-node Aurora instance. Correct answer is C.